This is a common scenario. You have a table here. In this case, it's a product table from an e-commerce store. In this scenario, I'm just recording information about books that I'm selling in my store. So naturally, I'd have here fields related to things I want to store about the book. So the title, the price, the number of pages, and so on. Maybe over time, or I know initially when I'm designing the database, that I also want to sell other products, for example, cupboards for the books. So at this point, I have a number of choices to make because, for example, if I were just to extend the table and now include fields related to the cupboards that I want to sell, so for example, the number of shelves, the height in the book, so I want to record information about that in my products table, I now have a problem. This problem might not seem obvious, but take, for example, we start to now add data to our table. We start to add the book data, so the category, title, price, number of pages, images, created, update. But then we have other fields here which will now be empty. Of course, it's the same problem now if we want to store our cupboards inside the products table. So, for example, here the number of the pages isn't applicable to a cupboard. Therefore, we start to have null value fields. So when I talk about null values, I just mean empty values in the table. So sometimes null values can mean different things. So the main point here is that when designing tables, where in this case, for example, a product we enter into this table will have empty fields, is negatively viewed from the perspective of database normalization. So the question is set, how do we design a product table for many kinds of products where each product will have different fields so that we can avoid any empty values in our table? A very warm welcome back to the Django ORM series. In this tutorial, we focus on extensible data modeling utilizing the Django ORM. So in this tutorial, I'm going to take you through four Django solutions that potentially is going to resolve our problem. Once I've discussed the first solution, we'll then give you some examples of solution 2, 3, and 4, so we can actually have a look to see at the performance and how you'd actually implement it within your application. Solution 1, concrete classes. So if we think back to our original class or original table, we had one table and we had lots of fields related to multiple products in that table. So the first solution here then is just to simply create a new table for every single product. I suppose the technical term here is that we're representing a hierarchy of classes with a set of tables. Every table will contain all the fields that are related to the corresponding class. So I'm not going to show you an example of this because this is simply just building a table, which I'm sure you're able to do. So let's just think about some of the benefits and drawbacks of this solution. So like everything I do, I try to avoid telling you what is the best way because there is no single best way for anything, because this is always going to be dependent upon the type of project, in this case, the amount of data that you want to save and serve and query on. That's going to be important. And then of course, there's a whole host of other parameters which need to be considered before you select your approach. So I'm just taking you through the approaches and thinking about some of the advantages and disadvantages of each. The concrete class or concrete classes, the advantages in this case are they are very self-sufficient. We have a single table, nice and easy to maintain potentially. And of course, one of the benefits of having this or utilizing this type of pattern, particularly if we're, for example, building a package for others to implement or integrate within their applications, this is a very simple table to integrate within just about any application. It's a single table, it's self-sufficient, it should work in that instance. Another point to note is, of course, it's a single table, so potentially it's nice and fast to run single queries on. Having a look at some of the disadvantages of concrete classes. The first is the field definition duplication. So imagine having 10 tables. We would have very similar fields in all of those tables that would be duplicated throughout those tables. So category, title, price, image. So that could be quite vast amount of data that we're storing, or vast amount of fields that we're duplicating, over these tables, and that could be perceived as a disadvantage. The second is the nature of how we're going to be able to query data in all of these tables. Because we don't really have any pattern in terms of a hierarchical structure of tables that might be synonymous to building database schemas and how we kind of access data through the root class maybe of a hierarchical structure in order to get data from different subclasses. Here we've got single tables that aren't connected in any way. So we would potentially have to run multiple queries or extensive amount of queries in order to achieve the data that we want to collect. This approach potentially is very costly then at returning data from the tables. Next up, we have solution 2, which is the multi-table inheritance. So I'm going to take you through a quick overview of this and then have a look at a Django example and then just go through how to explore or how to start exploring the query performance. Model inheritance in Django works almost identically to the way normal class inheritance works in Python. So here Django will create a separate table for both the child models and also the parent. So here's the example again from the start, the problem. Here we've got the product table, but this time we've got the generic fields inside of the product table. Now this is the parent table. Now what we do here is we create child models or child tables, and here we have, for example, cupboard and book, and that allows us to add the specific fields we want to include to model inside of these different classes here. So for book we want to store pages, etc., and then for cupboard we would want to store height and width and so on. So we're going to create, in this case, or this pattern, we're going to create 3 tables: the product table, cupboard table, and book table. So take a look at the example repository. You'll find the store and models, and you can see here we've got the product model, which is subclassing models.model, and here we've got the book and the cupboard, which isn't subclassing the models model. So be careful of that. This is how it needs to be set up. So you can see the reference there to product. And now we've got this set up, you can go ahead and migrate. So let's go ahead and do that. Let's make migrations and migrate. So let's have a look at the actual table now. So if I go into my extensions here, don't forget that I'm running, I've got SQLite. There we go. Let's just make sure we've got it turned on. Yep, so I'm running SQLite or SQLite. This is an application, or sorry, a extension that will allow me to view the default Django SQLite database. I can right click and open the database. It's going to appear at the bottom here. So I can go in and have a look here. So you can see that we've clearly created 3 models as I previously stated. So we've got the book, the product, and the cupboard model now created, or table created. So if we look inside of these tables, what Django is doing automatically is it's building a one-to-one field automatically back to the parent model, which is obviously the product model, and that's the same here in the cupboard. So what I'm going to do with these 3 examples is, in the view, I'm just going to generate for the home page all the products from those tables. So I'm just going to go ahead, and I assume you can do this. I'm just going to create a new super user and add some products to my tables. So go ahead and create a super user, no email, password, admin, and so on. Okay, so we're going to need to set up the admin area for this. So I've gone ahead, and in the admin here, I've just added some placeholders almost here. If we want to extend this for the product, book, and cupboard, at the same time, just registering those tables so we can have a look at them, or the default behavior in the admin area. Now, before we go into the admin area, I need to tell you that this has been set up with the Django debug toolbar. So this is already, if you download the repository, it's already set up for you. But if you want to set it up, you just need to pip install the Django debug toolbar, and then you need to go into your core and settings. At the bottom, I've got the toolbar panel set and also the internal IPs. So that's two things you need to do. Then further up, you'll need to add in the middleware. So just be careful where you place that middleware. It's just here in my case. And I've also then added the debug toolbar. So debug toolbar into the installed apps, the middleware here, and at the bottom here, I've got the internal IP and the debug toolbar panels. So once you've done that, head over to the URLs, and you'll need to just import that in, and then also just add in the URLs, and you'll be good to go. So one of the things here that's going to be slightly different because we have this tool on is that before coming to the actual admin area, you're going to be asked, so let's see if I can just simulate this very quickly for you. You're going to be asked, or the toolbar is going to see that you're trying to access the admin area. Just click on the link and then just click on the link again, and that just eventually will take you to the administration. So now we've set up the 3 tables in the admin area. Let's just look at the default behavior. So if we go into the products first, you can see that if we try to add a product here, you can see that we don't have any of the additional information about cupboards and books. So there's probably absolutely no reason for us to utilize this as it is, because we want to, when we add details about the cupboard or book, we also want to populate the products table, right? That's what we're trying to do. So if we go into the books or cupboard, you will see that we do have the fields from the products, and also then in this case the book at the bottom here. So let's just fill this in. Book 1. So we're just going to give us some information. I'm sure you know how to do this. I'm going to just skip this, add some products, and I'll see you in a second. So once I've gone ahead, I've added 4 items, 2 in the books, 2 in the cupboards. Now, if we look at the default behavior for the products, you can now see when we go back to the products table, we actually have the 4 products are entered. If we go into it, you can see that we can access all the data except for the specific information that's related to the cupboards or stored in the cupboards and books table. Of course, if we go into the cupboards or books table, we can access all of the data. So at this point, nothing is working at this point. So we just need to go into what would be the store and the views, and we just need to make some changes in order to actually grab all the data from both. So for each example, I'm just going to try and perform a query where I can collect all the data from each model and display all the data onto the home page here. So if I go into my view, I've just changed now this query. So I'm going to run product.objects.all. So I'm going to look for the products table. That's the parent table, obviously. And then I'm just going to extract all the data and display it onto my, the storefront here, or the index or the home page. So based upon the default behavior in the admin, the products table only showed us information about the products data based upon the fields that were inside the product table. And it didn't show us any of the fields that are associated or inside of the book or the cupboards table. So maybe that's what's going to occur here. So let's take a look. So when we look at the home page, we can see that the products are all displaying. All the products are being selected from the products table. Now, I don't currently have a setup where I'm trying to actually display any individual information about the book or the cupboard from those tables. So let's just go into our index page in the templates and index here, and just above price, let's just copy this, and let's say product, and we want to get the author, for example. That's the author found in the book table. So let's just see if that will actually get displayed. So nothing is returned there. So if we do want to get data from the related tables, we're going to just need to extend this and say product dot and traverse down to book and then the author. So that's going to collect the author. So let's just give that a go. refresh. You can now see we've got the author from book 1 and book 2. So that's how we're going to collect the individual information if you're using this type of pattern from the other tables. Or sorry, should I say from the child tables. So this is where it gets a little bit more interesting. Let's have a look at the toolbar here. So you can see that when we go down to SQL, it's telling us that we're running 8 queries on this page. So let's just delve into this. So let's have a look at what's happening here. So we're running this first query, select all from Django session, blah, blah, blah. So this is just session information. Because I'm logged in, I've created a session, a Django session. So that's absolutely fine. That's not really our concern at this point. And you can see that I've selected author user, where the author equals 1, because potentially I need to use that too. So that's just out of scope here. And also the category, I'm selecting the category. That's not something we're interested in at this point. So we're just interested in what we're trying to do here. So select all from store product, query by, or sorry, order by store product created. So here I'm selecting everything from the store. So store product, store being the app name and product being the table. So that's my first query. And first of all, I'm selecting all the data from the product table. Right, so that's query number 1. So once I've done that, what you can now see is that I seem to be iterating over this product table, and for every product I'm displaying, I'm running a separate query, because you can tell here it says select from essentially the book table where the product ID equals 4. So what's happening is I'm collecting all the data from the product table. Now I'm using that information. The ID essentially is going to match up the ID that's in the book and the cupboard table. So I'm utilizing that ID, the product ID, and matching it against the ID, the one-to-one field that's inside the book and the cupboard table. And to get every piece of information, I need to get all those IDs and query them individually, and in order to return the data. So hopefully you understand. Hopefully I wasn't, because I get a bit excited. Hopefully I wasn't too quick then. Hopefully you understand what's happening now. So I'm iterating, I'm searching, and I'm making a query for every single product that I'm trying to collect and display on the home page. Now, that's okay when I've got 4 items, but what happens when I've got 100 items and I'm, for example, producing some sort of pagination and I want to collect all the items? Now, that's when it gets a little bit costly to run this query potentially. And then, for example, I might want to, for example, have 100 people or 1,000 people accessing this page. So that's a lot of queries that are running just to produce all the data from the tables. So this is kind of like the fun bit, working out now, how can I reduce this load so I can produce more efficient SQL, and then potentially reduce the amount of SQL queries that I'm running, maybe try and get this to maximum, maybe 2 queries. Maybe that's the case. Maybe can I cut this down to maybe 2 queries or maybe 1 query? So is there a better approach? So let's first add some cupboard data. Let's just do the amount of shelves. I do apologize, I used author there, I didn't realize. It doesn't matter, but let's just put some cupboard data, so shelves, into the index here. So where we added the book information, we want to also collect, because at the moment we're not actually collecting any data from the cupboard. So let's just let's just get the author. No, shelves. Okay, so let's get these shelves from the cupboard. So let's just run that query again to see if anything changes. Okay, so now we have 12 queries. Oh, wow. So because we've added that extra data, we're essentially now doing a separate query to get that data. In addition, it looks like, to also getting the general information. So there's a lot going on here. So you can see how that's expanding fairly quickly, the amount of queries that we need to run. So let's have a look at some of the tools that we've got to try and reduce the amount of queries here. So the first one we have is the select related. Okay, so this works by creating an SQL join and includes basically all the fields of the related object in this case in the select statement. So essentially here we've got a select statement, products all. So this is a select all from products. And what we're doing now is we're using select related. Now we know what's related because we've made those related foreign keys, those one-to-one keys, or Django has automatically to the subclasses, the book and the cupboard table. So select related, then I've selected the two models, and this is going to, like I said, create an SQL join to include these fields when we create the SQL statement, which is going to produce less queries, hopefully. So let's go in and have a look to see if we can reduce these queries. We refresh again, and now we have 4 queries. So it's worth introducing two things here. First, select related, and then also the prefetch related. So these do very similar tasks. So let's just change this to the prefetch related, and let's have a look to see what happens. So here we're running 4 queries. Now if I refresh, now we're running 6. So the prefetch in this instance, like I said, it's very situational. This is running 6 queries. Now potentially here I'm just measuring based upon the queries. Now that isn't the whole picture, but that's all I'm doing in this case. So I'm saying, you know, generalizing here and saying the less queries is better. Now here's the thing, and it's worth reading into, but it looks as though the select related is essentially just running 1 query, while the prefetch, sorry, is running 2. So we could say that the select related is probably faster. However, over, for example, hundreds or thousands of models, potentially, or depending on the scale of your database, potentially the prefetch related could actually be better to use. So it's worth experimenting and have a look and understanding more about the select related and prefetch related, because like I said at the start, it can be very situational where you use them. So to try and give you an understanding, the select related is using a join in the SQL, whereas the prefetch related is running a query on the first model. It collects all the IDs it needs to prefetch, and then it runs a query with an in clause it runs an in clause in the where and all the IDs that it needs. So it's basically just how it works is slightly different. And like I said, it's very situational. I won't embellish any more apart from just to say have a little read into it because they are very useful tools. So I do hope that was useful. What I'm trying to give you is just some small snippets. I'm not trying to overburden you with lots of different information. I'm trying to be fairly specific, and of course there's lots of tools that we could discuss looking at the bigger picture, but it's good to know these small things to help us progress slowly into optimizing our application. So let's move on to solution 3, which is abstract models. So this is a slightly different approach. Now let's just go back to our model here. So this was solution 2, multi-table inheritance. Now in this case, we have a very similar setup here with the abstract method. But in this case, whereas the multi-table inheritance made a table, or Django made a table for each of these classes, what happens now when we use the abstract method, all of these attributes or all of these fields in our table, they will basically just get copied across to cupboard and book, as well as their individual components or fields that have been described inside of their classes or inside of their tables. So that's the key difference here between multi-table inheritance and then also an abstract method. So just to confirm, this product table isn't created. What happens is we're inheriting these fields from this from this parent, and this is all being copied or duplicated over to these new tables here, the cupboard and the book. So let's have a look at this. So just going back into our code, really there's just one change that we need to make here. So what we need to do is we need to describe or define this product table as an abstract table. So here we have abstract equals true. So obviously we're going to need to change the code here in the other file. So let's just go into the admin. Let's just blanket that out for a second. We're not going to need that. And of course, we just need to go into the store migrations. Let's just delete this migration. This is really annoying me. Move to the bin, and then we're going to delete our database, of course. So let's just remove that. So I'm going to go ahead and migrate, make migrations migrate. So I'm going to recreate these tables again. And then I just need to go ahead and again and just create a new super user and add some data. So I'll see you once I've done that. So I've created a super user. So let's just actually have a look at the database first. So let's go into the database. So you can see here we've got we should have the book in the cupboard. So we've got the book in the cupboard, but notice this time we've created an abstract class and we don't have a product table. So let's just go into the book table. You can see that when we go into the book table, like I said previously, all of these fields will be copied into the storebook, and that's exactly what's happened there. And that will be the same, of course, in the cupboard table. So you might be asking, well, what is the point of that? Because all we've done really is saved ourselves copying and pasting in these fields into these what are now, I guess, concrete classes. So what I introduced in the first solution, that's simply what we've done here. That's pretty much all we've done. So before we start adding data, actually, let's just now get rid of this migration. So that's the table we've just built. So let's just get rid of that. Right, let's just go back now and let's just name this a little bit more appropriately. So this is going to be our base, and then this is the book, sorry. So this is just going to, with the abstract class, this is basically just going to copy over these fields, as we know, into our new tables here, the book and the cupboard. So we've called it base. So let's go ahead and run with that. So what's the point of this? So what can we do with this? Well, what we can do is we can introduce a new class here, a new table, whereby we can create almost a manual connection between this table and both of these tables here. So if you remember in the first example, essentially we've created a structure whereby we go through the products table to get to the book and cupboard table data. That's what I showed you in the second solution. So we can manually create that in actual fact by creating a new table and utilizing a generic foreign key to manually or to select data from these two or more tables. So let's just run through this very quickly, the code. I don't want to type it out. Let's just paste it in. So I've created a new class here called product, and I'm just trying to generalize here. So this is going to be the product class, which is going to be connected to the book and cupboard. So I'm going to be able to access this data, the book and the cupboard data, through the product class here, through the product table. And what I'm doing here is I'm creating content type. So what I want to do is define the two or more tables that I'm going to use. So this is going to be essentially a drop down that I'm selecting. And when I'm filling in, when I'm creating this data here, I'm basically selecting the book table, or I don't know what says tree there, or the, what's it called? The cupboard table. Okay, so there's my models that I'm selecting. So this second item here is a positive integer field. So this is something that we're going to manually add. So what's happening here, if I can try to explain, when we add a book item, that book is going to have an ID. So what we want to do is we want to populate this product table with first of all book, and then secondly, we want to define the ID of that table that represents or connects to that particular book. So if we add a book, that's going to be ID number 1. So when we create a new product based upon that, we're going to insert number 1 in there and then select book in the first field. So what we're going to do now is generate or create a generic foreign key. And from that, we're going to need the content type, so the actual table we want to select, and then also the object ID, so the ID of the object that's inside of the book or the cupboard. And that's how we're going to connect the product table in a very manual way to the book and the cupboard or more tables. So hopefully that makes sense. Essentially, we're just building the product table we had before in the previous example, but I guess in a manual way almost. So we're going to need to bring in the tools for this. So we're going to need to bring in content type and the generic foreign key. Now, I know that I haven't given you an explanation here. I've just tried to give you an example of what exactly is happening here, and hopefully you kind of understand based upon what I've said, general terms, what's happening. So please go ahead and have a look at generic foreign keys, have a read through, and it's fairly simple to understand, and the content type too. Okay, so now we've got that in place. I think we can now go ahead and just migrate again and then add some data. So once I've added a new super user, I just need to go back into my admin again and just revert back my table. So I want the product, book, and cupboard table. So that should be okay now. So I should now be able to run my server. There we go. So I have made a super user. So I'm just going to now go into the admin area again. And then, like I said before, so I just need to click on these links that now take you to the admin area. And now we can explore the defaults here. So let's first of all have a look at the books. So it looks like, so hide this. When we add a book, we've got all the fields that we need. Wonderful. And that's going to be the same with cupboards. And then the products table, you can see we've got two selections, the table and then the object. Now this is going to be a manual process to begin with, but we could automate this with code, of course. So what we want to do here is we want to add a book and at the same time add the details here into the product. So that's going to be the content type and the object ID of that particular book. So when we make new data inside of the books, when we make new rows, that increments the ID, of course. So let's just add a new book. So I'm just going to call this book 1. I'll take you through one, then I'll add a few more. So is active publisher and author. So I'll save that. And now what I can now do is go into the book or the products, and then I can add a product. So I want the book and the object ID, which is number 1, and save. Okay. So I can now do the same thing for the cupboards. So I'm going to add 2 items. So next item in the products is going to be books ID 2. And then I need to do build 2 cupboards products and then add those into products. And that's going to be ID 1 and 2 as well, because I'm using a different table, remember. So the increment is slightly different because it's a separate table. So I'm going to go ahead and add those items. So I've added all those items into products, cupboard 1 and 2 and books 1 and 2. So now we can go ahead and go to the front end and do the same thing again as we did in the second solution and have a look at the queries. So head over to the views. Right, so we had this before. So let's just, oh, what am I doing? Let's just get rid of that. So let's bring in our query again. So we're using products again. So let's just try this out, product.object.all. So we'll save that. Let's go into the front end. We can find that. Let's go into our store again. And now we're going to refresh. So at the moment, it doesn't look like it's collecting information. So that doesn't look like it's useful. So we're going to need to make a few changes here. So let's have a look at the code. So here in our index page, you can see we're trying to loop through the data that we're returning from the database and then outputting the individual components, image and title and so on. So what we're going to need to do here is a simple change. We're going to have to say inside of the products that are returned, we need to kind of traverse and go into that data, that item, and then access that data. So here we're just going to add the item after the product in each section. So let's go ahead and do that. So product dot item dot author, and then item dot shelves. Okay, so we've added that data. Product, we can add this too. Okay, right, so let's go back in and refresh, and you can now see we've returned the data, well, at least some of the data. I think we've not included the price item dot price. So let's have a look at that. So there we go. So we have all the data back as per normal now. So that was a simple small change we need to make. So let's have a look at the actual query. So we're running 8 queries here. So it's a similar situation in that what we're doing is we're collecting all the data from the product table and then using those IDs to loop through each of those tables and looking for those individual items that have been collected from the products table. So one might imagine we can now go ahead and optimize that. So let's just give this a go again. Let's use the prefix related. So let's add that onto the end and just see if we can now collect the data. Now what's happened in here is it says cannot find book on product object. Book is invalid parameter to prefix related. Okay. So what's happening here is that we don't actually have a reference point. So let's go back to model. If you remember the second example, the foreign key was in the book and the cupboard. Here we're kind of doing a reverse in that the foreign key or the key is in the product table. Now what we probably need to add in the book and the cupboard is a related name. So what we need to do here then, if we go into our models, we need to build a many-to-many field over to the product table. This will be one approach. You can see we've created a related name and a query name. That's just some parameters we can add in. So we need a related name. So you can see here we've done the same thing in the book. We've made a many-to-many field in the book table, again connecting it to the product table. Now this is kind of a manual setup of the setup we've done in the previous example almost now. So now then, what you'll need to do is make migrations and migrate that. So once you've migrated, restart the server, come back and refresh. And you'll see now it's actually working. We're collecting the data again. So this is running the prefix, go back in, the prefetch related query. And you can see this time, in actual fact, we're running 12 queries now. So it doesn't look like, in this case, it's making too much of a, too many changes. So 10 queries, it looks like we're running. So I wonder, for example, in this case, if I now change this. So now let's move across to select related. Now this performed better, didn't it, in the first example? So what we're going to need to do here is change to content type. So we're going to need to select related content type. Now remember, content type in our model is defining our two models, book and cupboard. So essentially we're going to choose our two models or select our data from our models through the content type, book and cupboard. Now how that is formatted, if you remember, the format here is going to be the name of the app. So store underscore book underscore related. So what we're going to need to do here, in addition to the changes we made there in the view, is just go back into our related names in our book and our cupboard. And we're going to need to change it to store underscore cupboard underscore related to match the products table. So make those two changes in the cupboard and the book. Once you've done that, you'll then be able to go back into the front end and then refresh. And there we go, we've got our data back. So you can see here that we're still running 8 queries, which isn't ideal. So let's have a look at a different way of doing this. So of course, in this case, I'm kind of just leading you down to this path. This idea here, maybe it's not the best choice to go through the products table at all. Maybe we can just make a union of the two tables. Remember, the two tables we have, the books and the cupboard, they have all the fields already inside of those tables. So maybe we don't go through products here. Maybe we just make our own union. So here we are. Because I've mentioned union, I thought I might as well show you how to do this. So what we're doing here is we're going to take the two tables. Remember, these tables have all the fields already inside of them, or data. So we're going to collect all the data from the cupboard. That's one query. And then one query for the book, collect all that data. And then we're going to build a union. So we take the cupboard and then we kind of connect it with the data that was returned from the book. And then we just basically return that as one group of data, one table, for example. And then as per normal, we just send that across to our template. So now we should just be able to go back into our page. Now data probably needs to be sorted. So what's the problem here? Order by not allowed in subqueries. Okay, so orders by is not allowed in subqueries. So that means if we go into our models, you can see we have ordering here. So we're probably going to need to do that within the individual classes here. So you need to set that up separately in those different classes. So let's just go back to our front end. Okay, so let's not worry about the queries at the moment because we don't have the data. So we're going to need to revert back in our view. So we don't need, in our index, we don't need item anymore. So let's just get rid of item. I do hope you're following this. It's useful. If it is useful, just let me know in the comments. If it's not, if there's something I missed, well, there's lots of things I missed. So don't tell me what I missed. There is lots of things I've missed out here. There's so many different ways. It's just great. So I've reverted back now to that. And let's just go back in. I don't think this is going to work just yet. Oh, it does. Okay. So there we go. So what we have now is 4 queries. So it looks like we're being a little bit more effective here. So let's just go into our queries. That's great. So we're getting our session data. Now we've got the auth user because we're logged in. We're selecting the store category and also then select from store cupboard, union select all from store book. There we go. So now we have 4 queries. It looks nice and cleaner. Potentially that's improved performance. So I will note at this point, we only have 4 items in our database. Once we start scaling this up, these type of tools and these type of methods that we're utilizing, they may not be as effective. Of course, as I've already shown you, there are some tools that potentially work more effectively in larger scales of data, work at larger scale of data. I think I was right. So yeah, just have a go. Think about, hopefully that's given you some inspiration in terms of kind of helping you improve your application so far. Now there's one more to go. So let's have a look at the 4th approach. Solution 4 is django-polymorphic, and I do apologize. I made a mistake earlier in the first introduction slide where I named it polymorphism. Now, if you know a little bit about polymorphism in Django terms, you know that we have been actually talking about that more or less. So let's just move on to the django-polymorphic package. So this package is going to perform those operations that we've been doing on its own, essentially. So this is a simple way of creating the structures that we've been creating in our models. So have a look at the introduction to this and have a read through what this provides. But we're just going to install it and have a look at what it provides us. By doing that, you'll see what it's doing based upon the information that I've already given you. So let's go ahead and pip install. So yeah, let's just go ahead and pip install Django-polymorphic. There we go. Okie dokie. And then we're going to need to, look like, add it above the contrib content types. So let's go ahead and do that. So let's bring in our products. That's going to be in the core and the settings. So let's place it there. There might be a reason for that. I haven't read into that. Okay, so now we've got that. Making your models. Okay. Let's just go ahead and just tidy up here. Let's close everything down. Right, so first of all, we're going to need to go into our store and migrations. Let's just delete our migrations for now. Okay, and then also we're going to delete our database. Let's just do this manually quickly. And then also in our models, let's just go ahead and delete the product for now. We're not going to need that. And now we can have a look at what we need to do. Right, so we've got these models here. Looks like we're going to need to bring in polymorphic model in. So let's do that. Okay, so let's bring in that up the top here. Looks like it's unresolved, but we'll just ignore that for now. Okay, so we're going to have our product. And then let's add all the items into that. So here we're defining it as a polymorphic model. Okay, and then looks like we then have our child classes here. So let's go ahead and just add that into our product. Now here, if we make the product polymorphic model, then the children are also going to be classed as a polymorphic model. So all we need to do here is just add product. So let's just get rid of that. Okay, so that was simple. And let's have a look now at the documentation. I believe we need to do something a little bit different in the admin area. So just moving into the admin, we're going to need to bring in polymorphic admin, and then we've got our models as per normal. So for the parent admin, we're going to extend from there. So we're going to bring in we're going to create a base model here, base class, sorry, for all the childs. So model a child admin, and we're going to bring in the polymorphic child model admin. We're going to explicitly define our parent, and then we're going to go into what's going to be the book, which is going to be a child admin, and then also the cupboard. Okay, and then finally we then are going to use the polymorphic model admin here in the product. Okay then, so from the top you can see that I've imported the polymorphic admin, imported the parent model admin and the child model admin. I've then gone ahead and created this class called model child admin, and that's basically a class that's going to import, or kind of, yeah, it's a class that's going to include the two childs, book and cupboard. So you can see here we've added that to the model child admin, and then we've also defined the base model there. So that's all in, and then here inside of each of these classes for the childs, cupboards and book, you can see we've identified the base model and to show an index so that it's visible in the admin site. And then finally, this needs to be in order. So finally, we've created the product. We've created the product class here for admin. We've defined the base model and then also the class models. So now that's all defined, what you'll need to do, just go back into your models, make sure you remove the many-to-many fields, and then go ahead and make migrations and migrate, add a new super user and add some data. Now it's going to look very familiar. So I've already gone ahead and done that. So once you've done that, go over to the admin area and then just go to products and add a product. And notice we're given a selection here of book and cupboard, which is very interesting. And then you save that, and then you create your product as per normal. That's interesting. I'm not actually going to do that. I'm going to come out of that and then go back into products. Okay, so it didn't save. Okay, so let's go ahead and actually have a look to see what's in the table. It's going to be interesting. So we've got our new table, open database. So we've got a product table. Looks like we've got a book table and a cupboard table. So let's have a look in the product table, see what's inside of here. It looks like we've got all of our fields. Okay, and we've got this ID here, and then if we go into our cupboard here, you can see that we've got the individual fields. So that's kind of set up there in the table. It looks like we're probably running a many-to-many table, a one-to-one table from the cupboard to the product. That looks like what's happening here. So we can see what's happening here. So now all we need to do, of course, is go back into our views. Let's just get rid of this here, and let's just go back to a classic product.objects.all, and let's have a look to see what returns. So back into our site, we're going to refresh, and now we've got a problem here. So let's have a look to see what the problem is. Name products is not defined. Okay, maybe I've called my model product. Maybe that's the problem. I have indeed. So let's go back into here. Oh no, I am doing product. Okay, so there's a problem here. Products. Okay. So I just need to products equals product object. Oh, there we go. So I just need to add that into there. Okay. Now let's just go back into there and refresh. So it looks like I have my data, which is all good. So let's have a look at the performance here. So I'm running 9 queries. So let's have a look here. So so it looks like we're running lots of queries here. We've got the inner joins as you would expect. Now, this is great because I'm not saying that one thing is quicker than something else, because again, if we scale this up, you could probably see that maybe this polymorphic the polymorphic package, sorry, is maybe going to outperform. But here you can see that our previous examples potentially are running less SQL queries. So potentially in this case only, that this package might not be as effective as just creating it ourselves. So hopefully that was useful. Okay, so I've just done a refresh, and you can now see, in actual fact, I've reduced that. It's been reduced to 6 queries, which is interesting. So there may have been some other setups there. I didn't really read into the queries. So it looks like we're now running 6 queries. So if you remember, we did get that down to 4 queries. So again, that statement still applies. So potentially this will work in a larger scale, potentially more effectively than the other approaches. But now at least you know some different approaches that you can test and try against your data. So I do hope that exercise was useful, or provided you some insights into thinking about optimizing your queries, and also gave you some insights into different approaches for that particular problem that we set out at the beginning. Thank you very much for listening if you've got to the end. If you feel as though you want to support the channel further, please think about becoming a member of the channel. That's always good, and hopefully I'll see you in the next tutorial.